J. Students, is it okay? Stokes Law. What is Stokes Law? It is after the name of a physicist, Stokes, right? Hope he was American, but not sure. Stokes Law is what all about? You know, students, when a spherical body is falling through a viscous medium, when a spherical body is falling through a viscous medium, then it experiences viscous drag. You just imagine there is a long cylinder, glass cylinder, and having glycerine inside it. What?
Glycerine.
You have a spherical ball. You drop the ball. When you drop the ball will fall, but the layers will also have a relative motion. This is one layer. As the drop comes here, the layer moves and then breaks. Then second layer moves and breaks, and third layer moves and breaks. So this spherical ball experiences opposing force, that is called viscous drag. It is directly proportional to the radius of the spherical body. It is directly proportional to the velocity, and it is directly proportional to the coefficient of viscosity. For the time being, I am making you to move into the chapter number 1, units and dimension. In units and dimension chapter, you remember we do derivation of a formula using dimensional analysis. It's going to be a kind of revision. First of all, we collect the various terms like radius, velocity and eta. So F is equal to K, R to A, V to B, eta to C. What is F? First, its dimensional formula is M1 L1 T minus 2. What is K? K is found experimentally. So, what is R? That is length to power A. What is velocity? L1 T minus 1 to power B. What is eta? It is M1 L minus 1 T minus 1 C. Okay, students? Now, M1 L1 T minus 2, M to power C, L to power minus C plus A plus B, time to power dimensions minus B minus C. Now we will use principle of homogeneity. What do we use?
Principle of homogeneity.
You know, C is equal to 1, C plus A plus B equal to 1, and minus B minus C is equal to minus 2. C is what? 1. So minus B minus 1 minus 2. So minus B minus 2 plus 1 minus B minus 1. Minus gets cancelled. B is equal to 1. So B is equal to 1. C is equal to 1. Right, students? So C is what? 1. A we have to find. B is 1 equal to 1. This gets cancelled. A is also equal to
1.
B is equal to
1.
and C is equal to
1.
Then students, what is F? k, yes, eta to power c, that is 1, r to power a, that is 1, velocity to power b, that is 1. K is found to be 6 pi experimentally. You know, dimensional analysis of CBSE or board level, right? So therefore, F is equal to 6 pi eta RV. Students, this is what the viscous drag acting on a, this is what the viscous drag acting on a spherical body, which is moving through a viscous medium with velocity v, having radius r, having coefficient of viscosity eta. Any question?
No, sir.
Is it clear?
Yes, sir.
Once again, I tell you the step 1, F depends upon what factors? Radius, velocity, and coefficient of viscosity, that is eta. So we write F is proportional to R to A, V to B, eta to C. Removing the proportionality sign, we have to introduce constant. K depends upon what? K depends upon the experimental value. So dimensional analysis is silent about K. Now, K is found experimentally. So F का value m1 L1 t minus 2, radius length L2a, velocity L1 t minus 1 to b, eta m1 L minus 1 t1 minus c. So using the indices and using principle of homogeneity, you will find the value of A as 1, B as 1 and C as 1. So F is equal to 6 pi eta R. Clear? Now students, I like to explain you terminal velocity. Yeah?
Terminal velocity.
This is very important, and this is going to be a very important terminal velocity. Well, students, to understand terminal velocity, first of all, we'll go into the examination-oriented explanation and steps. The topic is terminal velocity. What? Terminal velocity. Students, this is a spherical ball. First of all, I will explain you board level steps, then we'll go in the side tracks. Is it going well?
Yes, sir.
There is a spherical ball, correct? Its radius is r. It is falling through a viscous medium. It can be air, it can be liquid. Liquid can be glycerin, honey, or water, whatever you like. Mercury, not mercury, so it's not possible because it will float over it, right? So, what is its weight acting? 4 upon 3 pi r cube rho into g. 4 upon 3 pi r cube is volume. Volume into density is mass into g. See, look here. The volume of the drop, the volume of the spherical body will displace the volume of the fluid, maybe liquid, maybe gas. So, the upthrust is 4 upon 3 pi r cube sigma into g. Sigma is the density of the fluid. And of course, students, there will be viscous drag. There will be viscous drag. Now look, as the spherical body is falling, viscous drag is increasing. A stage comes when upthrust 4 upon 3 pi r cube sigma g plus viscous drag equal to 4 upon 3 pi r cube into rho z. Now tell me, if the weight 4 upon 3 pi r cube rho z is balanced by viscous drag and upthrust, the ball will stop or it will move? You will say the ball will stop. It will not stop. It will move freely. It will move freely with a velocity which is called terminal
Velocity.
velocity. So 4 upon 3 pi r cube sigma g 6 pi eta r vt. Here velocity v instead vt, that is called terminal velocity. That is equal to 4 upon 3 pi r cube rho into g. Students, if you solve this equation, pick up a pen, notebook. If you solve this equation, you have to calculate Vt. Vt is called what? Terminal
Velocity.
You will find 2 by 9 eta. 2 by
9 eta.
r square rho minus sigma into g. R square rho minus sigma into
G.
I hope it is clear.
Yes, sir.
There is one question. Why it doesn't stop? When its viscous drag and upthrust is equal to weight, why it does not stop? You know, it is falling by virtue of inertia. It is in the state that no external force is acting. No external
Force is acting.
It means it is following Newton's first law. If the body is at rest, will remain at
Rest.
If the body is in motion, it will remain in
Motion.
right? And in the absence of the external force, the body remains in its natural state. The natural state was its motion.
Motion.
Absence of external force means upthrust plus viscous drag is equal to weight. So this is expression for terminal velocity. Students, have you seen clouds?
Yes, sir.
Have you seen clouds?
Yes, sir.
Akka?
Yes, sir.
Okay, good. They are floating in air. Are you sure?
Yes.
They are floating in?
Air.
No, they are not floating in air. They are falling slowly, slowly. They are falling.
Slowly, slowly.
Why so? Because the radius of the droplet of the cloud is very, very small. Therefore, Vt is proportional to the radius square. Smaller is the radius, smaller is the terminal velocity. So clouds are not floating. They are partially floating, but due to the wind, but actually they are falling freely. Students, have you seen a bubble in a soft drink? When you uncork it, it goes up. Have you seen? Why? Because the density of the bubble is less than sigma, then Vt is what? Negative. Vt is what? The
Negative.
bubble starts coming.
Upwards.
Maybe in the childhood you remember when you were a child, like still you are a child, there is a full bucket of water and you have a mug and you capsize means usko ulta karke aap pani mein
Yes,
when you
yes.
place it,
Yes.
then it comes drum. Why so? Because inside the mug or a cup there is air. Air has got a less density than the water, so it comes down. You might have noticed, students, if you have a paper bag, forget, recently a festival of Diwali has taken place. You might have seen a lantern, that you ignite and place one candle in a paper bag and it goes up.
Yes, sir.
Why so? Because it goes up. It's not parachute. It goes up like a hot air balloon. We call it hot air balloon. Because the density of the air inside the hot air balloon is less than the density of the outside air, so it is lighter, it goes up. So dear students, terminal velocity is clear, Stokes Law is clear. For the board level, it is very, very important. Kindly make it, right? And do send your, see students, the exams are coming up now, and exams are coming up now for the boards 11th and 12th, 10th, 9th. You can send me your queries and questions which you really want to cover on the YouTube, and I'll upload all those questions and queries with clarity, right? Thank you all. is well and clear?